Okay, this video is a continuation of the work we started doing in part 1. So in part 1 we integrated a and b. We also laid a foundation of the rules of how to tackle these type of integrals. So you might want to have a look at that part 1. So here we're going to start off with part C. So in part C, we have got cosine squared theta. So we said if the power or both powers are even, then we use the double angular formulas. And one of the double angular formulas says the cosine squared of theta is equal to 1 plus cosine 2 theta. So that means this thing we can write as the integral of 1/2 into 1 plus cosine 2 theta. So the good thing with this is that the power of cosine here is 1. So if the power is even, then we can use the first rule. Okay, but in this case we don't even need the first rule. We can simply integrate that. So integral of 1 is going to be theta. Integral of cos 2 theta, we're going to have to divide by 2 because derivative of this is 2. So it's going to be 1/2 sine theta, and that is going to be the value of the integral. And then in D we have got sine theta to the power 5. Sine theta to the power 5. So here the power is odd, so we're just going to follow the rule established. So we're going to save a sign. So that is the sign we've saved, and then all else, which means this sine to the power 4, we're going to have to write in terms of cosine. So using the fundamental identity of trigonometry, we know that sine squared is 1 minus cosine squared. So this sine to the power 4 is going to be 1 minus cosine squared all squared, because sine to the power 4 is sine squared squared. Then if we let u be equal to cosine theta, then du is going to be negative sine theta d theta, which means sine theta d theta is negative du. So our integral is going to be 1 minus u squared squared, because cosine is u. Then sine theta d theta is negative du. So this thing is going to be negative of, if we expand this, we're going to get 1 minus 2u squared plus u to the power 4. And so integrating this is going to give us u minus 2/3 u to the power 3 plus 1/5 u to the power 5 plus c. And then since u is cosine, so this is simply cosine theta minus 2/3 cosine theta cubed plus 1/5 cosine theta to the power 5 and plus c. So that is our D. And then in E we have got cosine to the power 5 over sine cubed. So cosine to the power 5 over sine cubed. Right, now both of the powers of cosine are odd. However, the sine is in the denominator, so that safe sign thing will not work quite nicely, because the saved term needs to be in the numerator. So the only way of going about this one is to save the cosine in the numerator, sine cubed here. So this is the term we are going to save. Then we're going to need to write everything else in terms of sine. So cosine to the power 4, all right? Let's just talk about cosine squared. Cosine squared, using the sine squared plus cosine squared equals to 1 formula. Cosine squared is going to be 1 minus sine squared. Cosine to the power 4 is cosine squared squared. So if we square this, then that is going to be cosine to the power 4. The denominator is in terms of sine, so that is all right. We saved a cosine, so we let u be equal to the sine. Now that we've written everything else in terms of sine, then du, derivative of sine, is just cosine. So this is telling us that this is just du. This is going to be u cubed, that's going to be u squared. So in terms of u, our integral is now 1 minus u squared, all divided by u cubed times du. So what we need to do is to expand the brackets in the numerator. Again, that's going to give us 1 minus 2u squared plus u to the power 4, all divided by u cubed. So what we want to do here is to use the distributive property of division and divide each of these terms by u cubed. So this is the situation we're going to have, and then we're going to integrate them term by term. So in the first instance, we've got u to the power minus 3. The second term is u to the power negative 1, or just 1 over u. The third term is just u. So if we add 1 and divide, so this one is going to be u to the power minus 2 all over negative 2. This one is going to be ln of magnitude of u. This is u squared over 2. Now u is sine, so we can write this thing as 1/2 sine squared theta minus 1/2 1 over sine squared theta. That's simply cosecant, so that's going to be cosecant squared theta minus 2 ln of magnitude of sine. We can rewrite this in the following form. It's going to be sine squared theta, just the log term, using properties of logs. You can write this as ln of sine squared theta plus c. So this is looking nice now. So I've got sine squared here, 1 over sine squared here. All right, so that is our example number E. now going to go to example number F before I give you some of the remaining ones to have a go at. In example number F, we've got sine theta to the power of 4. So that means cosine theta is to the power 0. Remember, 0 is an even number, so here both of the powers are even. So we're going to have to use the double angle formulas. So the particular one we need is the one for sine. So sine squared is 1/2 into 1 minus cosine 2 theta. So that's what we're going to plug in here. So 1/2 into 1 minus cosine 2 theta. Since this is sine to the power of 4, so that should be all squared. Then 1/2 squared is 1/4. Then if we remove brackets here, it's going to be 1 minus 2 cosine 2 theta plus cosine squared 2 theta. The first one we can integrate, no problem. The second one we can integrate, no problem. The third one, we still have the same issue of an even power. So we're going to have to use a double angle formula again. Remember, cosine squared theta is 1/2 into 1 minus cosine 2 theta. So cosine squared 2 theta is 1/2 into 1 plus cosine 4 theta. So if you double this, you double that as well. So the integral, so let's call this I. So I we can rewrite as follows: 1/4 into the integral of 1 minus 2 cosine 2 theta plus 1/2 1 plus cosine 4 theta. If we collect terms here, then that's just going to be 3/2 minus 2 cosine 2 theta plus 1/2 cosine 4 theta. Now both of these are now power 1 here, power 1 there, so we can integrate straight away. So if we do that, the first term is going to be 3/2 theta. This one is just going to be sine 2 theta, and this one is going to be 1/8 because we're going to have to divide by that 4 there, sine 4 theta, and then plus c. Okay, so right at this point we are going to give you an opportunity to have a go at the 3 remaining problems. So if you just want to have a go at G, H, and I, you can pause the video, work through them, and then when you press play again, then you can compare with our solutions. Alright, we're now going to scroll down to our answers for these 3 examples here. And if you have any questions, any comments on any of the material we're doing here, or you'd like us to do a particular topic, do feel free to post your comment in the comment section. And we're hoping you're finding these useful. Please do not forget to subscribe, like the video, and share accordingly. All right, so for G we have sine theta to the power 4 cosine theta to the power 3. So, and since this is odd, we're going to save a cosine, and then we're going to write everything in terms of sine, which means this one in particular, because this is already in terms of sine. So, and then of course cosine squared is 1 minus sine squared, and then since we saved a cosine, we make u to be equal to sine, du is going to be d cosine theta d theta, and then this is what the integral is going to be in terms of u, integrated and then rewrite in terms of theta. This one, both the powers are even, so we're going to have to use the double angle formulas. We've got sine squared, which is 1/2 1 minus cosine 2 theta, cosine squared 1/2 into 1 plus cosine 2 theta. Plugging these here, 1/2 and 1/2 gives us 1/4. These two are a difference of two squares, so we're going to have 1 minus cosine squared 2 theta, and then this is even again, so we've already shown this before, that cosine squared 2 theta is going to be 1/2 into 1 plus cosine 4 theta. So that's what we're going to plug in here. Simplify and integrate. Alternatively, we can adopt an approach similar to what we did in example number B. Write this as sine theta cos theta all squared, then use the sine double angle formula. So we're going to have sine squared 2 theta here, and then again, well, if sine squared theta is this, then sine squared 2 theta is going to be 1/2 into 1 minus cosine 4 theta. So if you double this, you also double that. Alright, and then if we plug this here, and then at this point you notice that this is exactly the same as this line here. So the integral is going to be exactly the same in this case. The two methods this time give us exactly the same answer. For this one, we are going to want to write everything in terms of sine and cosine. So the tangent here, we'll write in terms of sine and cosine. So we're going to have sine to the power half in the denominator, cosine to the power half in the numerator. Then the sine term, 7 on 2 minus 1/2 is 6 on 2, so it's going to give us 3, and cosine 1/2. So this is odd, so we're going to save a sign and then rewrite everything else in terms of cosine. Let u be equal to cosine, and then this thing in terms of u is going to be u to the power 5 halves minus u to the power half. We integrate, we plug in the original variable in terms of theta. All right, thank you for watching.